We've been talking a lot about all these microbes, fungi, and deadly diseases. So where do researchers study all these things? We're talking about pretty serious stuff here. That's why some research is done in special labs, like the ones you're about to see.
You sure this is it?
Yeah, pretty sure.
Looks like an ordinary old building to me. What did Dr. Bouye say when you told him you're doing a story on, what was it?
Dangerous viruses and bacteria. Maybe even viruses that bioterrorists might use as weapons.
Are you serious?
Well, yeah, since we're doing a story for the school news, he thought it would be a good way for students to learn about research in biolabs.
Biolabs? It sounds kind of like James Bond, top secret.
Martinez. Alex Martinez.
In that case, after you, Martinez.
So I do research on pathogenic microbes, bacteria or viruses. Now, pathogenic means that these are capable of causing disease in animals or humans. So what made you decide to do research on this particular topic?
Well, Sydney and I have actually been doing stories about contagious diseases that are spread by virus and bacteria through the school, and we just did one about staph on our wrestling team, and it was pretty wicked. But then we started looking at big diseases, like in Africa and other places where people are actually dying from them.
So you probably heard about Ebola, Lassa fever, Rift Valley fever, and yellow fever. Now these are viruses that we have no treatment, no vaccines for.
Yeah, I mean, they seem pretty serious. I heard that they're spread through the environment and they can actually be transmitted person to person. But then I read about how terrorists are actually using the really bad bacteria to infect bunches of people.
Unfortunately, that's true. You've probably heard about bioterrorism in the news.
Like the anthrax scare?
Right. Anthrax spores were put into envelopes and mailed to people. Some people became ill, some people died. Anthrax is a disease that's caused by bacteria.
If they can figure out anthrax, maybe it's easy for bioterrorists to use all kinds of microbes to attack people.
No, generally it's hard to do. We just need to be prepared in case it happens.
Scary.
Yes, it's scary to think about, but that's why labs like the one I work in are so important. It allows us to work safely with some of the most dangerous microbes.
So you do germ warfare research?
No. Germ warfare is when someone like a bioterrorist uses a bacteria or virus to make people sick, like the anthrax attack. What we do is biodefense research. There's a big difference.
Well, what exactly is the difference?
In biodefense, we're coming up with methods to detect the bad bugs or germs that bioterrorists could use. We're also working to develop ways to protect and treat people who are exposed. But it's important to understand that these bad bugs or germs are those that are found in nature. An example of the disease is the West Nile virus that was found in New York in 1999. People were getting sick, and it was all due to the bite of an infected mosquito.
Okay, like this is so unreal. Bioterrorism, big labs, strange diseases. I mean, this kind of stuff is on video games. So of course I was in. And Sydney?
This is really weird, but I love it.
All right, now we need some background information. Our next stop, Dr. David Walker. Dr. Walker knows a lot about the study of pathogenic virus and bacteria research. He's the director of the WRCE.
WRCE stands for Western Regional Center of Excellence in Biodefense and Emerging Infectious Disease Research, but you can just call it the WRCE. It's here in Galveston, Texas, at the University of Texas Medical Branch. You can just call that UTMB. We're called a regional center because we've combined forces with the surrounding states to do research. And what we do research on is trying to find ways to diagnose, treat, and prevent dangerous infectious diseases of humans.
So is this where you do research on stuff like anthrax?
Yes, not only anthrax. We do research on about 30 different infectious diseases, including Rift Valley fever, Ebola, typhus, influenza. Many of the best researchers in the world can work in these labs that we have available here.
Here? Is it safe?
Well, that's a good question. Let me say first, yes, it is safe, but it's not just a lab that you and I could walk to. It's called the Biosafety Level 4 laboratory, or BSL-4. And it's airtight, so that none of the germs can get out. And you have to work very special procedures inside to make everything safe.
But does it look like an ordinary lab?
Well, once you get inside, it does. But you have got special procedures to have to get in.
Now, is this the only one in the entire United States?
No, actually, we're one of 4, but it's the only one on a university campus in the United States. Dr. Michael Holbrook is the director of the BSL-4, and he can answer some more questions for you.
Thanks. So what does BSL-4 mean?
BSL-4 means Biosafety Level 4. It's the type of lab environment that is built in order to help contain microbes that are very dangerous. And the lab is designed and built in order to contain these viruses and make the researchers able to work safely with the different viruses. In other words, the microbes are contained. So there's 4 different types of biosafety levels, from Biosafety Level 1 all the way up to Biosafety Level 4.
Okay, now how do you tell the difference between these labs? I mean, they all pretty much look the same, right?
They really do all look the same, but the biggest differences are in the way they're designed and the way they're built to work with the different organisms we use in different containment environments. And actually, probably the best way to understand what the labs look like is to go and have a look for yourselves.
BSL-1 labs are the lowest level. Researchers work with microbes like the bacterium Bacillus subtilis. It's found in the soil and may contaminate food, but rarely causes food poisoning. Microbes studied in this lab are unlikely to cause human disease. Level 1 labs are often teaching labs for future scientists. In Level 2 labs, researchers work with pathogenic bacteria and viruses that can cause human disease. But these are not easily spread through the air, where a person could inhale microbes and become ill. Here the worker takes more precautions than in Level 1, wearing gloves and a lab coat, and working in a biosafety cabinet. In BSL-2 labs, researchers study agents that cause diseases such as measles, salmonella, and rabies. Now let's add a protective gown, a double pair of gloves, and a mask. Work in Level 3 labs involves pathogenic viruses and bacteria that can be spread through the air. These pathogens can cause serious or life-threatening diseases, and there may be no treatment and vaccines. Workers use the same precautions as in Level 2, but add more, so they don't become ill or expose people outside the lab to dangerous microbes. Also, BSL-3 labs are kept under negative pressure, which means that the air pressure in the lab is lower than the air pressure in the surrounding areas. Air flows into the room rather than out of the room to reduce the chance that an airborne microbe could escape. Researchers study diseases like anthrax, typhus, and SARS, a serious respiratory illness that may have started in China. And then there's the chief of them all, BSL-4, the highest level lab, where some of the most infectious pathogens on the planet are studied. These are mostly pathogenic viruses that can be spread very easily through the air and have a high mortality rate, which means more people could die if they are infected. Workers in this lab take many precautions, as you'll see.
Wow, so the big viruses are studied in the BSL-4?
Yes, the deadliest. But that's why we have the submarine inside the bank vault.
A what?
The submarine inside the bank vault. It's designed in a way that the inside lab is airtight and the outside is built out of super strong concrete. It can protect against strong hurricane winds and other elements.
A submarine within a bank vault?
Exactly.
I was adding to my vocab each day that I worked on this story. Pathogenic microbes, biosafety level labs 1, 2, and 3. I was starting to get the lingo down. And then there was UTMB, WRCE, and the mysterious BSL-4 lab, which I was finally going to find out more about from the very people who work there. We were about to enter the biozone.
It's like entering another world. You don't have the sights or sounds from outside, a breeze from an open window, or smells. Everything is strangely quiet, except for the sound of the air in your protective suit. Even if you're working with other people, you can't hear them very well. You end up using sign language just to communicate. So, mostly you concentrate on the movements of your hands, thinking about your next step, and doing very careful, safe work. It takes a special kind of person to work in a BSL-4 lab. Some people don't mind working up to 8 hours in isolation without having access to their email or cell phone. Other people, even if they don't mind working, still need to take a break from the lab and relax and check out MySpace even. So, as you can imagine, we get lots of training, especially science classes, starting in middle and high school. We take our safety and everyone's safety very seriously.
You're about to begin work at the BSL-4 lab for the day. Make sure you leave yourself enough time. It will take you from 30 minutes to an hour just to get ready. If you think the building and hallways surrounding the lab as being the bank vault, and the inside room or actual lab as the submarine, this will give you an idea of the layers lab workers need to pass through before they reach the lab. The many indicator gauges tell the researchers the lab is safe to enter, including the air pressure indicator. It's in the safe zone. Researchers are ready to dress for work. They don't wear the usual jeans and t-shirt. In the suit change room, they check their spacesuits for air leaks. This is a must so that the researcher breathes only the air that is pumped into the spacesuit through the air supply hoses, and not the air in the lab since it could contain a virus.
We always check our equipment.
After researchers put on their suits, they connect to the air hose and inflate their suits. Researchers use their ID cards to enter through another door. This is very high security. The fresh air in the hoses is the same air that you breathe in every day, except this air passes through special filters. The hoses are only about 10 feet long, so the researcher will hook and unhook the hose to move around the lab and check equipment. Once the suit is inflated, it will keep enough breathing air for 3 to 5 minutes. It's time to go to work. But what if a container with a dangerous pathogen spills and releases viral microbes into the air? What happens then?
Not to worry, the lab is under negative pressure, meaning that the air inside the lab is at lower pressure than the air on the outside of the lab. So if anything gets spilled, everything is contained within the lab. All of the air that comes out of the BSL-4 is specially filtered so that it doesn't get out into the environment and doesn't infect people or animals. And everything, including the lab workers themselves, are thoroughly decontaminated before they come out of the lab.
So if bioterrorists were actually successful at using these dangerous microbes, people would freak out.
Well, bioterrorism is still a very real possibility, but there's also the possibility of naturally occurring infections. In this case, BSL-4 labs are here to protect the people, not to endanger them. The possibility of anybody entering the lab who doesn't belong is very, very remote. Along with all the security that we have in place, even if somebody does get inside, we don't have enough virus in there that could be used to harm large numbers of people.
That's good to know.
It's all about training, safety, and having experienced people who work in these laboratories who know how to work with these very dangerous microbes. And at the end of the day, the people who work here know that what they're doing could make people all over the world much safer. And that makes 8 hours inside of a spacesuit well worth the effort.
I feel like we're stuck in the lab and we're never going to get out.
Well, we better think of an ending before we run out of air. Doctors Bouye and Holbrook just finished for the day, and it was time for them to emerge from the depths of the lab, the submarine, back into the routine of civilian life. They passed through the door of the lab and into the shower. Not your typical suds. It's a chemical shower to decontaminate the suit.
Once they are decontaminated, everything must be checked once again. They hang up their suits, remove their coveralls and socks, take regular showers, put on their street clothes, and finally, they're ready to call it another day at the BSL-4.